Okay, so in our last video, we had talked about this other definition for sine and cosine. We said that if you think of the world, I guess, as a unit circle, so that you got ones here and here, and you consider any point on the circle. All right, so you can make a little right triangle doing this right here, and we figured out that depending on what this angle is right here, it's going to determine your point on the circle. Now, the cool thing is that the x value of that point was the same as the cosine of that angle. That's what we figured out in that last video. And similarly, the y value was the sine of that angle. So this is the way that we're going to start thinking of our sine and cosine, and it's going to really be helpful. All right, it's going to help us to go beyond these little 90-degree angles. I mean, the 90-degree angles and everything, they were okay. But we want to figure out bigger problems like cosine of 135 and sine of 120. So if I'm looking at our unit circle here, the way it works is, the x value is cosine and the y value is sine. So if I punched in cosine of 40, I'm going to get some value and it's going to match this x coordinate. But as I move this point along the circle, am I frozen? Nope, I'm not frozen. There we go. As I move this point along the circle, my angle changes. And so here in quadrant 2 at 140, I still have some x value and some y value. Well, however far to the left that is, which is like negative 0.8, it looks like, that is going to be the cosine of 140 degrees. Or how high it is, the 0.6, that's going to be the sine of 140. All right, so the x value is cosine, the y value is sine. And you can continue rotating here. At 180, the x value is negative 1, and the y value is 0. Okay, so that's how far up and down it is. So that's why sine of 180 would give you 0. All right, so it doesn't matter where you are on the unit circle. You can always play that game. But the only ones we're going to focus on are going to be our special angles. So today you're going to need to have this little sheet handy and also that spider web. So all you just know the sine, cosine, and I don't even remember if I've taught you tangent yet. I probably have. You just know sine and cosine of the angles in quadrant 1. Well, as it turns out, that's all you need to know because you can use those to figure out the other ones. All right, so here I go. I'm going to start with sine of 120 degrees. All right, so 120, so rotate 90 and then rotate 30 more. That's where you're at. So because sine is like the y value, we just want to know the y value of that point. We want to know how high it is. All right. Well, what I'm going to do is I'm just going to kind of relate it. I want to relate it to a quadrant 1 angle. All right. So hopefully you can tell, it's the angle that's high. It's way up high, I guess. So what I'm doing is I'm just reflecting it across this y-axis. So I'm really looking at this angle right here. I'm really looking at the 60-degree angle. Well, if you have your spider web, you know that sine of 60, all right, the way that worked for sine, it was 0, and it was 1 over 2, and then root 2 over 2, and then root 3 over 2. So this is root 3 over 2, which means it matches this height right here. All right, it's the same y value, same height. So we get square root of 3 over 2. Okay. If we want to do sine of 5 pi over 4, I'm going to have to rotate until I get to 5 pi over 4. So this is going to be 1 full pi plus 1 pi over 4. So I'm right here. Now the thing to notice here is because we're in quadrant 3, the y value is negative. All right, so our answer to this question is going to be negative. We need to relate it to this quadrant again, and hopefully you can tell it's the 45-degree angle because it's the one in between these two. But if you can't, you can just reflect twice. So you would reflect to the 45 over here, and then reflect to the 45 over here. Okay? So what we're really dealing with is sine of 45 degrees. Let's see here, sine and cosine. Yeah, at 45 degrees, those are the same. So it was 1 over 2 and then root 2 over 2. So square root of 2 over 2 is the sine. It's the sine of that angle, but it's negative. All right, so we related it to that quadrant 1, and we were really just concerned with the y value at that spot. And it turns out it's going to be this. I'll punch it in on the calculator so you see here. First off, my mode. I'm in degree mode, so I'm going to have to enter in 225. Sine of 225 is equal to negative 0.707. Well, that's the same as negative root 2 over 2. All right? So that's the y value at that spot there. Let's do a fresh one here. This time, we'll look at cosine of 135. So 135 is right here. And we want to know what that x value is this time. So because we are, to the left of 0, I know that the answer to this is going to be negative. All right, again, we want to relate it to some quadrant 1 angle. Well, in this case, hopefully that's pretty clear. You just reflect it. You're really dealing with that 45 degree angle again. All right, so cosine and sine, they are equal at the 45 degree angle. So this is going to be root 2 over 2 again. And then because we're in quadrant 2, the x values are negative. So this answer is going to be negative right here. All right, cosine of negative pi over 6. So remember, pi over 6 is just a 30 degree angle. But since we're going negative, we're going to rotate clockwise. So we're talking about this position right here. Now, you want to relate that to the quadrant 1 angle, so you reflect that up. So you're really just still talking about the 30 degree angle here. And cosine of 30 degrees, I think for cosine you went this way. So 0, root 1 over 2, root 2 over 2, and root 3 over 2. Okay. Root 3 over 2, and because we're in quadrant 4, the x values are still positive, so the cosine here is still positive. Right? If you wanted to, you could type in cosine of negative 30 degrees, and then type in root 3 over 2, and you'll see that they are the same value. Okay. Now I guess the other ones to think about and remember are going to be the ones that are on the the actual axes right here. Right. So these are important to remember as well. So right here, the y value is a 1 and the x value is a 0. So sine of 90 would be a 1 and cosine of 90 would be a 0. If you're over here, the x value is negative 1, but the y values are 0. So cosine of 180 is negative 1. I'll put the coordinates here, negative 1 comma 0. And the y value there, or the sine of 180, is equal to 0. So, you can do the whole thing where you plot the point, where you plot the point and then try to reflect until you're back over here. And that does work that way. But the more and more you do it, you're going to start getting a feel for, is this further to the left, this spot right here, or is it further up? And that's going to help you to determine whether it's 1 over 2 or root 3 over 2. And it really depends on which trig function you're talking about. Last bit, just make sure you know this, have this somewhere in your notes or in your head floating around. It's the sines. All right, remember, when you're in the quadrant 1, both x and y are positive, so you get plus and plus. So both are positive. In quadrant 2, the x values are negative and the y values are positive. So this would be, cosine is negative and sine is positive if your terminal side ends in quadrant 2. So like, if it's any of those angles there. And then in quadrant 3, it's negative and negative, left and down. And then quadrant 4, it's positive for the x values and negative for the y values. So that's a good thing to have also in your